Okay, so the part you've probably mostly been waiting for now, we're going to go on to the practical components. A couple of things though first I just want to point out. If you look to the top here and the bottom left, you can see that my environment is hosted on GitHub Codespaces. This is not essential for you to use this notebook. You might have a local version of Jupyter installed, or you might even have Google Colab or some other kind of similar service. I know Notable also offers a similar service. The second thing I want to point out is you'll be able to see here that I've actually got a bash kernel installed for my Jupyter notebook. So this means that I haven't got to prefix my commands with any kind of symbol. So I'll be able to just put them straight into the cells. The other thing that I just wanted to point out is I have annotated this notebook quite heavily. I won't be going through all of these annotations today because we'll be going through it on the code, but I just wanted to point out that there's a lot of annotations here that I will be hiding as I go through this notebook with you, but just please expand these cells, or I might just expand them again before I leave the link up for download. Just read through these. And potentially you might find them quite beneficial, especially if you're using this as a reference guide after the video ends. So just wanted to point that out for you. What I'm now going to do is I'm now going to collapse all of these markdown cells, and we're going to go back to the start of the notebook. But hopefully you'll find some use out of these annotations. So just before we jump into the code, I just wanted to quickly just give you a sort of behind the scenes look at my origin. So origin in the respect of Git, if you remember from our presentation, the previous videos. So this is going to be the remote that I'm going to be using. I'm going to be using GitHub. So if you look on the screen now, you'll see there's a repository that's been created, git-demo. I haven't actually put any files in this repository. I haven't played around with it at all. I have literally just created it in GitHub. And then in addition to that, I just want to point out that I will be using SSH authentication. And in my case, that SSH authentication is already been set up prior to this this interactive demo. Your authentication needs might be different. You might be using username and password, and that's fine. The commands will still work the same. It might even be that you don't even have a remote, or you don't want to set a remote up, but you do want to just play around with Git locally. And then when it comes time for us to look at the origins and look at remotes and stuff, you might just want to sit back and just watch that part. And it's all good. So however you want to proceed, but I just thought I'd show you behind the scenes of my setup before we get started. So with that being said, let's jump back to the notebook. Okay, so we are back in the Jupyter notebook, and as you can see, I've closed all of the markdown cells like I said I was going to do. I do urge you to have a look inside these cells and read them if you have the time, or if you get stuck on a particular part of this notebook. I have tried to put some little caveats in there, some gotchas, some pro tips, and all that good stuff. So let's start off just preparing our workspace. So this is what this command is going to do for me. If you're not familiar with Bash, all I'm doing here is I'm deleting this folder if it already exists, just by forcing it, doing it recursively, and then making that same directory back again. This is just in case I want to make this folder multiple times later on, and then I'm just doing a change directory to change into that folder. Once I've changed into that folder, I'm using the echo command to echo in to two files here, the strings. This is a test file and second file. I don't actually need the ease there. I was actually going to do something like this, just to put some additional lines in there. Otherwise, the ease are not necessary. So I'm just going to run this command, and I've now created my folder, and I've actually put my two files in my folder. I'm using the pwd present working directory command just to confirm that I'm actually inside the directory, and that's what the change directory command would have done. And I'm now just going to list out, just to prove that I've only got these two files in that directory, and I'm using the full syntax to show hidden files. And you can see here, I don't have anything other in this directory other than those two files that I just created. So now I'm going to initialize our repository like so. And if we look again, and I just click this command again, you can see we've now got this .git folder inside of our project, and we've just initialized our first Git folder, our first Git project. So we're on a good track. Okay, so with our Git directory created inside our working folder with the git init command, let's have a look at what goes inside this Git folder. So I'm just going to use the ls command on the Git folder. Ignore the first two items. If you know anything about Linux, you know that these are not going to be relevant to this discussion. These are just like the parent folders and Linux nomenclature. But if we look at the first actual proper file, and we can see it's a file because it doesn't start with a D. The first proper file that we have inside this Git folder is the head file. Now, this is a file that references the current branch, or I should say a pointer. So it's a current pointer to the branch that we're actually on. So we could have loads of branches within our repository, but the head is always going to point to the branch that we're currently on in our working folder. And this might make more sense as we go later on. Branches, so this directory was used very early on in very early versions of Git, but it's not really used any longer. So do not worry about the branches folder too much. This is mostly going to be historical for these future sessions. The config file, so this file basically contains the configuration for the Git repository. So this will include things like the origin URL, it will contain the user's email and the user's username, and other repository specific settings. The description, so this is not really used anymore as well. There is something called Git Web, which is like a Git web interface, and it's part of the default package that we can install from Git, and it basically gives us a web interface for our repository. This file is typically used with Git Web. So again, we're not going to really be looking at this file during this the demonstration. Hooks, this is, and I've actually got another video on the channel where I looked at hooks, but this directory contains script files that are to be executed when certain Git events occur. So like a pre-commit or a post-commit or a pre-rebase. I know we haven't talked much about rebase, but just know that these are actions that can take place in Git, and we can set hooks. So when these actions take place, they run scripts containing code. The info directory contains the exclude file, which works like a .gitignore file, but this is not checked in with our repository. So it can be used to ignore files and pass for this repository only, but we can't check it in. So we can use it as a gitignore, but we cannot check it in. So that's the difference there. Objects, this directory contains all of the blobs like file content, trees, directory content, commits for our project. This is basically the heart of the Git storage system, really. And then, as we talked about in the slides, Git uses references. So this directory contains pointers to commits. It has subdirectories for the heads, tags, and remotes, etc. And this is what includes our references. So moving on then, the first command we're going to look at is the Git Status command. So this command here is a good command to memorize because this command will give you the status of your local repository. I'm going to run the command now and we're going to talk through what it shows us. So we can see here that we're on the main branch, no commits yet, so we haven't actually committed anything. We've got some untracked files. Now, the Git status message is actually your friend a lot of the time. People gloss over this screen, but it's actually very useful because as our code changes, the Git status screen will actually give us some good hints. So we can see here we've got 2 untracked files, and it's already given us a hint here. And we looked at the git add command during the presentation, and it's saying to track files and to put them in our staging area, which will be what's committed. So to track our files, we can use the git add file command. So at the moment, it says nothing added to the commit, but untracked files are present. Use git add to track. So this is a good little hint for us. So we can see now we're on the main branch and we've got 2 untracked files. The next command I want to talk about, because this is a command that you will quite often see when you initialize a new GitHub or similar service repository. And I just wanted to talk about it because you'll see it a lot. Let me just actually flick to the other screen actually, and I'll just show you my GitHub repository. So I just wanted to quickly jump across here because one thing you would notice is from the Git Status command is we're actually already on the main branch. But you can see here that in the Git setup for both of these, we have this Git branch with the -M main. And it might sound counterintuitive for you, but as I mentioned before, there's been a strong movement to go from master to main as the default name for Git repositories. And so what this command is actually doing is it's actually forcing a rewrite of whatever the initialized repository name that you had, and it's actually going to force it to be rewritten to main. So if you initialize your Git repository and by default you have a different branch name, this is forcing the change of that branch name to main to coincide with what GitHub has set up. If you do want to change this for whatever reason, if you just go to up here to the settings, so if we go to settings here and we go down to repositories, you're able to see here that we can actually change the default repository branch as we still see fit. For this particular lesson, main is fine. However, you can see here that you can change that setting if you so wish. Okay, so we're back onto our notebook command line, if you will. So I just wanted to show you what this does. So in this case here, we are already on the main. You will see this on GitHub, like we just saw, and maybe some other services. In this case, it's not going to do anything because we're already on the main branch. But if we just run this command here, you can see it's run with no errors. If we were to change this to what should we call it? Development. Let's call it development. So I just run that now. It's basically forced the rewrite of our branch. So you can see now we're on the development branch. Nothing else has changed. We just changed that branch name. In this particular case, I'm going to move it back to main, like so. Okay, so moving on now then. So we're going to start looking at the local workflow of Git. So if you remember in the presentation, there was a couple of different stages of this process, and we're going to go through them all in quite a lot of detail. Okay, so let's break this down then. So in the presentation that preceded this, we talked about the git add command. By using the git add command, we are going to be staging our changes. So if we just go back up our last Git status, we can see here that we've got 2 files and both of these files are untracked. And it actually tells us here, use the git add command to include what will be committed. So let's just do that now. So now we've added our file, let's just do git status again. And now we can see that we've got one file here that's waiting to be committed. And you can see here, actually, it says to unstage our file. Therefore, we can tell that this file has been staged. So this is our staging area. We have one new file, which is file1.md, and that's the file that we added up here with the git add file1md. We've still got, though, the second file, which is untracked. And you can see here that it's telling us that if we've made a mistake or if we don't want to put this file in that commit, we can actually just remove it using the git rm cache file command. So if we run that now, like so, we haven't actually deleted our file. We've just removed it from the tracked staging area. So if I look at my git status again now, we've gone back to how we were before. There's no files that have been staged. And we're actually now at a situation where we're back to where we were, square one. So moving down, let's just have a quick look at our file system. We can see our two files are there. We haven't lost any files. The git rm cache command does not delete files. So just as you see this rm, this is not the same as like on the Linux terminal when you do rm. We are just removing this from the cached files, okay? So let's go and add a file again and go back to what we were. And if we just quickly go back up to Git Status just to prove, we've now got one file in the staging area. Now let's commit that file. So I've just put a little message here, something helpful about what I did to file one. Notice that I'm using the inline syntax. I could just go to the command line and do a git commit, and then it'll pop up with an editor, the default Git editor. In this case, I'm doing it on the command all-in-one because I'm working inside an interactive notebook. But let's just commit. So we've done our commit, and you can see here that we've actually had part of a SHA-1 hash that we talked about in the presentation come back. So you can see here this AF6EAOE. That's the start of our SHA hash, and you can see that we've committed on the main branch here. And we've got two insertions, one file changed. The reason we've got two insertions is there is 2 lines in that file. So let's do a git status. And we can now see that we've actually only got one file that's untracked changes. We're on the main branch, but we've now lost that message saying that we haven't got any commits. So I hope you can see the difference to that now. So back up here, it said there was no commits yet. We had this staging area and the untracked files. Down here, you can see that we've got untracked files and we're on the main branch, but we haven't got the no commits, which means we have got commits. So let's have a look at our commits. So to see our commits, we can use the Git Log command, and I've got 2 variations of it here. We previously discussed about did we discuss it? I think we did in a previous video. If not, we're going to go through it now anyway. But we've got the sort of default syntax here for Git Log. So this is the standard command that gets run by default with no options. And you can see here, I've got a commit message, and that message is tying in with the message I just put up here, something helpful about what I did to the file. And we can see that message here. We can see who did it, that's me. We can also see the date, and we can also see the start of that SHA hash that I was talking about before. So if you remember when we were back up here, we had that SHA hash from the A to the E. If we look down here, we've got the SHA hash, and that's the start of it from the A to the E. The other thing is, if you remember, we looked at references. So our head is now pointed at main. If we don't want to know the times and the who's and the what's, then we can use the Git Log one-line function, which will reduce the output slightly, but it'll allow us to have it on one line, which will become much more easy to work with when we have lots of commits. And later on, we'll also look at how we can manage these commits and merge them. So it's always an idea to have both of these commands in your toolbox. So if I just run this now, you can see the difference here being there's no author information here and there's no date information here. So that's just something to bear in mind when we look at the Git Log command. So next we're going to touch upon the concept of remotes. So we talked about remotes in the presentation, and the default remote is typically origin. Well, that is the default remote, but you can set additional remotes that might not be origin. So we'll have a look at the Git Remotes command next. Now, you'll typically see the Git Remote command run with the V option on it for verbose. There is a slight difference here. So if we take the V off, we'll just show our Git Remote. If we add the V on, we'll also see the URL for the actual repository. Now, in this case, I don't have a remote, I'm still in a Git repo, but I don't have remote set. So you can see here the command hasn't actually returned anything because we haven't got a working remote. Now in the next line, we're actually going to add a working remote. So if I add this here, Git Remote add origin, and add the GitHub repository link, you can see once I've added that remote, I now have some remotes listed. Now, I mentioned to you before that we can have more than one remote. So this repository doesn't actually exist. This is a GitLab repository. I've just basically used the same structure as this URL here. And while I do have a GitLab, this is not a valid repository. I'm just using this to make a demonstration. But I could have Git Remote add GitLab. Now, in your situation, GitLab could be upstream. It could be dev environment, production, whatever it is. There can be some very complex workflows that we can achieve using Git. The main thing to note, though, is this is a name that you're going to be given the remote. So if I do Git Remote add GitLab like so, and now I check my remotes again, you can see now that I actually have two remotes. I've got the GitLab remote and I've got the origin remote. And if I just check my Git status again, you can see that adding our remotes has not changed anything to our actual files. We're still on our same repo. We've still got that one file committed, and we've got one file with untracked changes. So nothing there has changed. So what we're now going to do, now we've got this commit, and we see that commit by using the Git log. So if we just go back up again, if we just remind ourselves, we've got this commit, we've got our one commit, and this is the first commit that we have. Let's just push that Git commit to our origin. So we're going to do a Git push origin main. And we're also in the main branch working directory. So we've done our Git push, and you can see there that we've pushed to, and here's our repository. You can see it's the GitHub one, and of course it would be that one because that's where our remote is. We specified it with origin. Now the other one wouldn't have worked, but it doesn't actually hurt to have multiple remotes listed, which is also potentially a good lesson. Just because there's remotes existing, it doesn't necessarily mean they're valid. You can configure non-valid remotes. Now it won't work, but just so you know, if you go into a repository, do Git Remote V, and you see remotes there, it doesn't necessarily mean that they're still active or working, but that's just something to bear in mind. So what I'm going to do now, I'm just going to do a Git status again. And you can see now, nothing's actually changed in our local repository, okay? I'm going to look at the local file, which is cat file 1. And as I said before, there was 2 insertions because this is 2 lines. What I'm now going to do is I'm just going to go to the repository, and I'm actually going to make a change to file 1. So that's what we're going to do next. So here we are, we're back inside our repository, and you'll see that we've just made our commit message. And if we look at this commit, and we click on it here, we'll actually be able to see that the commit name is the same name that we give on the command line. And if we wanted to look at the char hash over here, we can see that that AF6EAOE is present again, and that's how it's represented in the GitHub interface. If we click this, we can see that we've got our 2 insertions made to this one file, as was mentioned on our notebook. So what I'm going to do now, I'm just going to go back to the code editor. Now, if you're in the code editor, you can just press, on GitHub anyway, you can just press the full stop, and that will take you into a web version of VS Code where you can make some edits to your files. You might find it handy and beneficial, or you could just use the file browser. What I'm going to do here is I'm just going to put a little comment in here, and I'm going to say from the remote, like so. And I'm just going to commit that. Now in VS Code, if I was to commit that, I'll just come over here and I would just do a commit and push. Now in this case here, I'm just going to put message from remote. I'm now going to commit and push, and this is going to do it in one step for me. If I was to use this drop-down arrows, you can see I've got the option of continue to work on, but I've got commit and push. That has now committed that code and it's pushed that code. So if we go back out to our repository, you can see now that we have 2 commits, and our latest commit is this B1 BB6F9. If you don't want to use the interactive editor, you can just come in here and manually change a file. So just click on a file, use the pencil up here. I'm going to say another change from the remote. Like so, I'm now going to commit my changes, but because I'm actually on the origin, so this is the remote origin, I don't actually need to push any changes. I'm working directly on this origin. So on this remote, sorry. So you can see there, now I shouldn't have actually done that really, that was a bit poor taste, but the update file one is my commit message. If you're part of a team, you need to get out of the habit of just doing these generic updates or fixed stuff type messages. But the point is now I've just made another commit, which is this new one, 374. And if you look at the commit history, so let's go to the commit history quickly. You can see now that we've actually got 3 commits. The reason this is saying verified, this is because I'm actually logged in to GitHub as I'm doing this. This is not from the command line. So that's why you're seeing the difference there. So let's jump back to the notebook and let's carry on with the lesson. Okay, so I'm now back on the command line, and where we left off was me catting out the file1 file. And you can see here that at that time it just had this is our test file. So if we go down now, the opposite of pushing is pulling, and we talked about this command in the presentation. If I just do a git pull origin main, I'm going to pull what was on origin down to my local branch which I'm in, which is main. So you can see here now some insertions have happened. In total, only 1 file changed, and that makes sense. We only actually changed the 1 file. And you can see there's actually 2 insertions. So if you remember, between the 2 commits that we actually did 2 additional lines. And then if you see here, we can see that initial commit that we were on, and we can see the commit where we ended up to. Okay, so this is all giving us clues now. So we know where we are. Let's have a look now at that file. So we've now got the 4 lines that we saw on the remote in our file, and we've pulled in those changes successfully. Moving on, let's have a look at branches. So the git branch command is what's going to allow us to see what branches we have in our repository. If I run the first command out of these 2, by now you can probably have a good guess. Let me just go up to the top of the screen actually. So you could probably have a good guess that the one with V is going to be a more verbose, and the one without the V is going to be less verbose. However, let's just run them, and I'm going to go click now. And as you can see, we're on main. We know we haven't created any branches, so main is the only branch that we could be on. If I do the V option, what we can also see now is we can see that update, that SHA-1 hash that we committed, and we can also see that last commit message, which is actually ugly, update file 1, not really a good commit message, because anyone looking at the Git log and looking at the history will see that the change happened to file 1. What would be more interesting here would be to give a name that represents what happened during that commit. Did you fix something in the authentication or the logon page? Did you add some custom CSS styles? Those kind of things. So as we've only got this 1 branch, let's create a second branch. So by itself, without anything else after it, with the exception of the V, we're just going to be listing branches. But if we actually add a branch at the end, now this is just my nomenclature, it's quite popular. but you'll get people making branches, and they might even have things like bug fix. This branch one here, that's just meant to be representative, just so we can keep a track of this branch. But realistically, if you were doing something like fixing a login page or fixing some authentication, this branch name really should be something a bit more meaningful. But because this is a demo, I just want to give you a very clear, easy to understand concept. So this is going to be the first branch in our feature branch series. Again, you haven't got to have this /. We won't go into why I'm using this / now, but you could, if you wanted to, just make a very simple name branch like that if you wanted to. But we'll come into this, and I'll explain why teams use this methodology upcoming. So just bear with me for a moment. But if we just do now Git branch, we've now created our first branch. Nothing came back on the terminal, but if we look at the Git branch with the verbose command, you can see now that we have 2 branches. So we've created 2 branches for the first time. Okay, so with our branch created, let's go down now and look at the Git log command that we looked at before and see what we can see. So as we look at this, there's a couple of things that stand out. We can see that we've got 3 commits, and we can see here's the SHA-1 hashes of all those 3 commits. We can also see a reference, the head reference, which is pointing to the current branch that we're on. And we're on main, so this is where we are currently. This is where we are inside our working directory. However, what it's also telling us is that the feature branch that we just created, because we created it at this particular commit and we branched off with those changes, the feature branch 1 is actually at the same commit, which is this 374DB. But also it's saying that our remote origin is also at this commit. So all 3 are at this commit, our working directory, which is on the main branch, the remote origin, and our feature branch. Now, what you'll also notice when you looked at the git branch command, even though we created a branch, we are still on the main branch. And also, if we just also look here as well, the 374DB 8, you can see here that when we created this branch, because we branched off from where we were, the feature branch and main branch are both pointing to the same place, like I just said. So if we come down here now, what we're going to do is we're going to use the git checkout command. And if you remember, we also talked about the switch command, which could also replace the checkout command in this instance. And we're going to use this command to switch over to our feature branch. And you can see now that we've switched to feature branch. So if I do this git branch command again, let's just put this up a little bit. So if I do git branch again, you can see now that the asterisk is no longer in front of main like it was before. So if you go back up here, you can see that we were currently on the main branch as indicated by this asterisk, but also as indicated here by this head reference. So if we use the git log command now, you can see that the head is pointing to the feature branch 1, but also because we've made no changes, both the main branch, the feature branch, and the remote origin is still pointing at this commit. And if we go back to the browser as well, we'd see that this is the same SHA-1 hash, or at least the start of it. So let's move down and just get this screen fill. So what we're going to look at now, when we switched to the feature branch, we actually switched with the checkout command. And like I said to you in the presentation, the checkout command has a lot of advanced features and nuances on it, and we're going to look at them further down this notebook. But right now, to switch back, rather than use the checkout command, I'm going to use the Git Switch command to switch our branches. And you'll notice we're getting the same effect as when we was doing the Git checkout. So, switch to branch. Okay, now if I do the Git branch with a verbose, you can see now we're back on main. Again, we haven't changed anything in regards to these commits. And if I go back to a Git status, you'll see that we've still got this one file 2 that's untracked, and you can see that we're back on this main branch. I'm now going to look at something slightly different, and that is the creating of a branch, but also switching to the branch at the same time. So rather than doing Git branch and then feature branch 2, what we're going to do here is we're going to do Git checkout with the B command. And what that's going to do is it's going to create this feature branch 2, and it's also going to switch to it. And I should actually just point out these quotes are not actually needed. I don't know if that's been some kind of autocomplete, but you can just do it like this. So what we're going to do now is we're going to do a Git checkout with the -B. Now this time we've switched to a new branch. So last time when we created that branch, we didn't move to it. We just created it. We created feature branch 1, but we were still on main. Now you can see we've actually moved to feature branch 2. And if we just do a Git log, you can see now it's going off the screen a little bit, but you can see that we have the head reference pointing to feature branch 2. And you can see that all of the other branches and the remote origin that we have are all on this same commit. Okay, so let's just move this down the screen now, and let's have a look at how we can delete branches. So if you remember the presentation, I said that you can't delete a branch that you're on. Now, we just switched to feature branch 2, so we're not on feature branch 1. So what we could do is we could do a Git branch with the -D, and this would delete feature branch 1. Now, if you remember what I said in the presentation, this will only work if we've already merged our changes, or if we have those changes and they exist. Because we haven't made any changes to feature branch 1, it will delete with no fuss. If we needed to force it, remember, we've got the capital D option. But in this case, I'm just going to do a Git branch and I'm going to delete it. And you can see now deleted feature branch. If I do Git status, I'm still on feature branch 2. I've still got the one untracked file, so nothing's changed. I'm now going to add an additional file. Bear in mind I'm on feature branch 2, so I'm now adding a new file called file 3 to feature branch 2. I'm now going to do a Git switch main. I just want to show you something here. So if I do a switch back to main, because this file that I created here, it wasn't tracked in any branch. It wasn't even, I didn't do the git add command at all. And because I didn't do the git add command, when I do a git status here, you'll see that I've actually just got 2 untracked files, and nothing here has been committed to any branch. Now, if I just switch back to feature branch 2, I'm going to use the git add command, and this time what I'm going to do is I'm going to use the dot nomenclature, and that will be any file in the repository that's untracked. And there's times that you want to use this, there's also times that you might not want to use this. So with your commits, it really is a good idea to try and stage your commits to make sure your work is complete. And what I mean by that is I don't want to give too many specific examples that might not apply to everyone's needs, but let's say we have a page of HTML, so some web markup, and we also have a file of CSS code. Well, that CSS code and that HTML code might go hand in hand, so it might not be a good idea to commit those 2 files up separately or with a whole other bunch of files. It might just be that you want an isolated commit with just those 2 files and just those 2 things changed. And there's lots of reasons why. It does actually make your life a lot easier as well if you can group your files into meaningful commits. So I'm just going to run this command. Now, at this point here, if we just went back to the Git status, you can see I'm on feature branch 2, and there's 2 new files here that have been staged. So let's commit these files. So I've just committed those files. We have a new commit, and you can see here F8E5C50 is the new start of that SHA. And if we use the Git Log command, you can see something a bit different now. So the head reference is pointing to the current branch, and the current branch that we're on is feature branch 2. And you can see here, that's the start of the SHA that we just talked about. And here's my commit message. However, the other two files, the other file and the other branches, they're still on this commit. So we can see here that our main and the remote origin main is still tied to this commit SHA, but we're actually a little bit further ahead. So we're pointing at this commit SHA. So if I just do it on a one line, maybe it might be beneficial for you just to maybe see it in an easier way. So if I just do Git log one line, thanks to Copilot there, the autocomplete, thank you. And you can see here, just on that one line syntax I told you about, you can see now a little bit more clearly our head references pointing to the current branch, which is the feature branch 2. This is the latest commit on that branch, but our remote origin and our local main is both on this commit here. I'm now going to git check out to the main, and this is where we're going to start to see some differences. So now if I do a git check out main, previously we've always seen these untracked files. So if I do a git status now, you'll see it actually says we're on the main branch, but there's nothing to commit and the working tree is clean. So this is interesting now. So as I do this ls command to list the local file system, think what you might see in the local repository. Now I'm going to give you the answer anyway. So what you're going to see now is we're just going to see that one file, that file 1. So the reason being is file 1 was tracked to this branch, this main branch. However, file 2 and file 3 that were untracked have now been staged and committed to feature branch 2. So if I go and check out to feature branch 2 again, so we just switch back to feature branch 2, and I do the ls command, you can now see that I can see all 3 files because Git feature branch 2 has knowledge of all 3 of these files. And if I just do a git log, you can see now that the head is pointing back to feature branch 2, and that's where I added file 2 and file 3 to feature branch 2. Main that we just switched to a minute ago, when we switched to main, we would have been here in our commit stack, and we would have only known about this update file 1. The reason we don't see the other 2 files is they are no longer untracked. They are tracked, Git knows about them, and Git knows that they are associated with feature branch 2. So I hope that is clear from that point of view. If I just do a git log one line just to see this as a one line, so you can see here now we're on this commit here. The head reference is pointing to feature branch 2 where we added file 2 and 3, but when we switch to our main branch, we only have that knowledge of file 1 because file 2 was added after this commit and file 3 was even created after this commit. So let's just do a git checkout main, and then we'll do a git log one line. Now you can see here that we don't have the same number of commits because inside here we don't have the knowledge of what happened when I committed those files and committed those files on feature branch 2. We're actually still back here on the stack. So you can see now if I started to move forward on the main branch, you can see how these branches start to diverge. Okay, so let's have a look at merging now in Git. So let's just scroll down a little bit more. So we're on our main branch, and you can see that here, their head is pointing to the main branch. What we're now going to do is we're going to merge in our feature branch 2. I'm not sure why these quotes are present. It might have been a GitHub Copilot trying to help me out or something, but just going to do a git merge. Now Now you can see here that I was on this commit char. You can see the 374db-d8, and I've just updated it. And we talked about this fast forward process in the presentation. So this fast forward process has happened because if you look here, we had no extra changes on our head branch, on our main branch, the branch our head's pointing to, this branch here. We had no more changes since we went off and diverged on feature branch 2. So what's going to happen here is Git's going to fast forward, and essentially we're going to have this additional commit added to our commit history. So that's what the fast forward is going to be doing for us, okay? And then you can see here that we've had file 3, 1 line, file 2, 2 lines, 2 files changed, 3 insertions in total. So let's have a look how that looks now on the Git log. So you can see now that we're on main, the head reference is pointing to main, but also we know that feature branch 2 is the same. And we know that because we were just up here a minute ago. So that was our feature branch 2. And now what's happened here is both feature branch 2 and main are pointing at the same commit. But our remote origin has no knowledge of this, and it's still that one commit behind. If we use the Git branch with the V, you can see we're on the main branch, and we have merged in our changes. So that means that we can do a delete if we wanted to on our feature branch. So we're going to merge in our features that we've just created. So let's do that now. So we've now deleted that branch. And if we just run this again, you can see that we've deleted that branch. And if we now do a Git log, you can see that our head is pointing to main. We have no sight of that feature branch because it's now gone, but we can also see that our remote origin is pointing to this commit here. So we need to now tell our remote about the additional changes. So we can do that with git push origin main, which let's do that now. So we've now pushed. And already you can see now what's happening. We're going from this commit to this commit. And if we do a git log, we can now see that our remote origin and our head, sorry, our main are on the same commit. And we can see that the head reference is pointing to our main branch. So now if I should do that on a 1 line, just to make it a little bit more visible, you can see here that origin and our local main are both pointing to that same commit, and we have no additional branches. Okay, so to finish this notebook off, I just want to have a look at some work with Git Remotes, and then in future videos on this series, we'll have a look at some additional more advanced topics moving on. So let's just scroll up a little bit. So we can use the Git Remote command as we've seen multiple times in this presentation. I really hope these commands are being drilled home now. So I'll just do the Git Remote. We can see that we've got 2 remotes. Now this syntax obviously is showing us 4 lines because it separates out the fetch and the push. We'll go into this at some point, but for now, if we want to see a shorter syntax, we can just use the Git Remote command. And this is enough for what we need to remove a remote. So in this case here, GitLab never existed and we never used it. So I'm just going to come down here and I'm going to do Git Remote remove GitLab like so. And if we just use the Git Remote command again, you can see here now that we've actually deleted our GitLab origin. So I hope that was beneficial and I hope we all learned something. Like I said in the presentation, I'm going to be going over these commands again and again to make sure they really stick. At this point though, you've probably mastered about 95% of what you're going to need to use Git for on a daily basis. There is some obviously advanced parts of Git that we will touch on, and we're going to look at things like rebasing and cherry picking and things like that. As we get onto more advanced stuff, we'll probably start working outside of the notebook, which is why I've kind of ended the lesson here for the notebook. But please download the notebook, read the notes, let me know if they help. Also leave a comment if you do like this series. Going forward on this channel, I do want to continue with the the series is on Bash and Git and the things that we've started, I am debating whether or not to change the channel name. So I might change this channel name soon. I'm not sure if YouTube penalizes Evil Saint as a pair of words. I'm not sure, but I am going to probably rename the channel. Naming the channel after my pseudonym was probably not the most clear way of describing what the channel teaches, which is basically either hacking tools or programming. And in addition to that as well, I'm also thinking about starting a new channel, because the last month I have been working on a whole batch of videos on AI. So looking at OpenAI, Anthropic, looking at Hugging Face, and all that kind of good stuff as well. So we've got all that to come. I'm just wondering if I should put that on a dedicated AI channel. By all means, let me know in the comments as well. But if you made it this far, thanks for your time. That was mine. And until next time, look after each other and yourselves. Peace.